In the previous session, I talked about chemical reactions of amines. In this fourth session, I am going to discuss about organic compound containing nitrogen, especially diazonium salts. We'll talk about diazonium salts in this session. Let me write over here. Diazonium salts. An organic compound with the general formula Rn2 plus X minus. So this we call it as diazonium salt. So try to know organic compound with the general formula Rn2x. Above N2 plus we need to write, above X minus we need to write, that is salt actually, and we call it as diazonium salt. The general formula is Rn2 plus X minus. In this case, this R stands for aryl group. So try to know R stands for aryl group, whereas the X stands for, that may be Cl minus or Br minus or HSO4 minus, or you can consider BF4 minus also, not in particular halogen, that may be HSO4 minus or BF4 minus also. So where R stands for aryl group and this X stands for these different kinds of groups you can consider. So in this particular general formula Rn2 plus X minus, so we have a N2 plus group. So try to know this N2 plus group, we call it as a diazonium group. So try to know this particular group, we call it as a diazonium group. Azo stands for nitrogen, we know. Diazonium, 2 nitrogen atoms we have, that is particularly ion. So N2 plus group, we call it as a diazonium group. So general formula is Rn2 plus X minus, where N2 plus group we call it as a diazonium group. We'll see examples for that, how we can write a diazonium salt. So example I am going to consider, since we know this R stands for aryl group, I consider phenyl group, that is benzene ring, C6H5 N2 plus and Cl minus. In the place of X I am going to consider Cl minus. So the name of this compound will be, let me write here, this we call it as benzene diazonium chloride. So this we call it as benzene diazonium chloride. Usually we can represent it as BDC, benzene diazonium chloride. So benzene ring we have, and on that we have diazonium group, and chloride we have here. So this is the one very familiar example for diazonium salt. One more example I can consider, C6H5 N2 plus HSO4 minus. The name of this compound is benzene diazonium HSO4, that is nothing but hydrogen sulfate. Hydrogen sulfate. So this is how we can consider some examples for diazonium salts. So organic compound with the general formula Rn2 plus X minus is considered as a diazonium salts, where N2 plus is called diazonium group. And here the examples I can consider, this is frequently used one, BDC stands for benzene diazonium chloride. So now, as we know how actually diazonium salts are prepared, we know that when amines reacts with HNO2 nitrous acid, we get respective alkyl diazonium salt, or you can say aryl diazonium salt. So now we compare the alkyl group as well as the aryl group of diazonium ion, and we'll talk about the stability of that. So what I am going to discuss now here is, I am going to consider the first thing, that is aryl. So let me write over here, I consider aryl N2 plus, that is arene diazonium ion, and I consider one more, that is Rn2 plus, this is alkyl. So let me write over here, so this is arene diazonium ion, whereas this is actually alkyl diazonium ion. So out of these two, which one is stable? So let me say that the stability of arene diazonium ion will be more, that is more stable when compared to alkyl. The only change is in the place of R we have aryl group and we have alkyl group. As we have seen, alkyl diazonium ion is highly unstable in nature, and after hydrolysis we get respective alcohols, whereas arene diazonium ion or the salt of that is quite stable. So why this arene diazonium ion or respective salt is stable? We'll see the reason for that one. So the reason I am going to explain that by considering the structure of that. So let me draw the structure of arene diazonium ion. So we have a benzene ring with N triple bond N, and here let me write a plus because 3 bond pairs for nitrogen we have extra plus I am going to write. So this is nothing but that is arene diazonium ion, Ar(N2) plus we have. This is ion actually. So now what happens, this plus indicates that the nitrogen is electron deficient in nature. So because of that the pi electrons will shift over here and 1 pi electron will shift on the nitrogen. So here I am going to write the resonating structure of that. This is the symbol or double-headed arrow mark that indicates we are going to write the resonating structure for that. So let me write the structure, what happens after this. So double bond we have here, and this pi electron has been shifted, so therefore you will get a plus charge, okay, and double bond we get N, and 1 pi electron has been shifted, therefore double bond N we get, and we have plus and we have minus over here. So a pi electron has been shifted, and the shift of electrons I have written, the position of atoms will be same, whereas the position of electron is going to be differ. That is nothing but the resonating structure. And we can extend this resonating structure. So this plus we have, therefore this center is electron deficient, therefore this pi electron will shift here. So when this pi electron is going to shift, the resonating structure let me write here. So pi electrons we have here, so pi bond, and here this is electron deficient, and this term I will write as it is, N double bond N, we have plus and minus. So one more resonating structure I am going to consider where the pi electron is going to shift here, and let me write that what we are going to get. So we get electron deficient here, double bond, and here we have N double bond N minus and plus. Later on this pi electron is electron deficient, therefore the pi electron will shift here and this negative ion will shift here, and we get back the original substance. So totally 5 resonating structure. I can write one more for that, how actually the resonating structure of this is going to take place. So let me write here. So the last one, the resonating structure, and here we have a double bond, okay, and now if you observe that we get N triple bond N and a plus over here. So this is the initial one and this is the last one. Totally 5 resonating structures we got, and this is the ion, in particular arene diazonium ion. So what happened actually, there is a delocalization of pi electrons, you can say. So because of delocalization of pi electrons in the benzene ring, because of resonance effect or mesomeric effect, you can say, therefore arene diazonium ion is stable when compared to aryl alkyl diazonium ion because of resonance stabilized. So this we call it as resonance stabilized. Because of resonance there will be delocalization of pi electrons in the benzene ring, and because of that this ion, in particular arene diazonium ion, is stable. So this is how resonance stabilized we can call it as. Whereas if you consider Rn2 plus alkyl, where R is nothing but electron donating group and only inductive effect takes place. So this alkyl diazonium ion is not stabilized by resonance. There is no chance of resonance because there is no delocalization of pi electron since absence of a benzene ring or aryl group, we can say. So because of that reason, what I am going to say here is arene diazonium ion is stable, more stable than alkyl diazonium ion, because arene diazonium ion is stable by resonance, whereas alkyl diazonium ion is not stabilized by resonance. Therefore arene diazonium ion is more stable in nature, and we have n number of compounds of that acts as intermediate, and because of that we can carry out we can synthesize many aromatic compounds by considering arene diazonium ion as the intermediate. That is how the stability can be predicted, and this is how we can write the resonating structures, and because of resonating structures stabilized by resonance, I can say. So now we'll see how we can prepare these. Preparation of diazonium salts. Preparation of diazonium salts, as we know, and arene diazonium ion are more stable, and this is highly unstable. Okay, of course on hydrolysis we get respective alcohols. So now we'll see preparation of that. As we know already, when we consider amine C6H5NH2, this is primary amine, aromatic amine, aniline, right? When this reacts with HNO2, what is that HNO2? Nitrous acid. As we know, nitrous acid is produced by combination of sodium nitrite and hydrochloric acid, and this reaction has to be carried out in 0 to 5 degrees Celsius temperature, or you can write in terms of Kelvin also, 273 to 278 Kelvin, means at lower temperature, cold condition, this reaction has to be carried out. And what happens when we take the mixture of these? So we are going to get what actually the benzene diazonium chloride we are going to get. So this we call it as benzene diazonium chloride, and after that we get some other products like sodium chloride, and 2 amounts of water we are going to get anyhow. So this is how the benzene diazonium chloride can be prepared. Remember that aromatic primary amine like aniline reacts with the nitrous acid, which is produced by the mixture of sodium nitrite and hydrochloric acid at very low temperature, about 273 to 278 Kelvin or 0 to 5 degrees Celsius. Benzene diazonium chloride is formed. Remember that this preparation of benzene diazonium chloride has to be carried out at a lower temperature only, because this benzene diazonium chloride or arene diazonium ion, what we get, that is stable at this temperature only, because when you increase the temperature, and that may hydrolyze, and benzene diazonium chloride is stable at cold condition itself. So this is how we can prepare the benzene diazonium chloride from the respective primary amines, in particular aniline, I can say. Physical properties also we have for this. Actually benzene diazonium chloride, or in general diazonium salts, are crystalline solids. They are soluble in water and they are stable at cold conditions only, as I mentioned. Whereas if you increase the temperature, and hydrolysis of the benzene diazonium chloride takes place. Chemical reactions of diazonium salts. Let me write over here. Chemical reactions. I classify the chemical reactions of diazonium salts into 2 different categories. One is the chemical reactions involving displacement of nitrogen. One more is the chemical reactions involving retention of Azo group. So 2 different classification I make. The one is the reactions involving displacement of nitrogen. Anyhow we know we have a nitrogen in a diazonium salt that can be replaced, that can be displaced by some certain ions. Such kind of reactions we are going to discuss under this heading. Second one is the retention of Azo group. So this particular group is Azo group. So Azo group will remain as it is in some chemical reactions. That nitrogen is not going to be displaced, and that we call it as coupling reactions or retention of Azo group. So first let me move with the displacement of nitrogen, and later I am going to talk about the retention of Azo group, so that we can write the reactions of diazonium salts. Reactions involving displacement of nitrogen. The first kind of reaction, let me move with that. So A is reaction involving displacement of nitrogen. So we can displace a nitrogen by some kind of nucleophiles. In that first one I am going to move with displacement of nitrogen by halide ions or cyanide ions. Displacement of nitrogen of diazonium salt by halide ions or cyanide ions. In that we have two well-known named reactions. The first one is Sandmeyer's reaction. Sandmeyer's reaction. Named reaction it is. And in this particular case, the nitrogen is going to be displaced by halide ions like Cl minus and Br minus, or cyanide ion, Cn minus ions of benzene diazonium chloride, and respective halide of benzene we are going to get. So how we can write these reactions? So just observe here. So now I am going to consider ArN2X, that is nothing but arene diazonium halide. So when this reacts with, I consider three different nucleophiles. So the first one, let me move with that one. So when arene diazonium halide, or in particular chloride you can consider, when it reacts with CuCl, that stands for cuprous chloride, in the presence of one halogen acid, that is HCl. And the second condition what I am going to consider here is when the same diazonium chloride reacts with the CuBr in the presence of HBr. And in the third case, I am going to consider CuCN in the presence of KCN. So HCl, HBr, KCN, respective halogen acids we have. So we have Cl minus, chloride ion, bromide ion, and cyanide ion acts as nucleophiles. Remember that I considered CuCl. Name is cuprous chloride. As we know, copper has variable valency, +1 and +2. Cu plus 1, cuprous, Cu plus 2, cupric. So this is cuprous chloride. Try to know the oxidation of copper here is +1. In all these cases, the oxidation of copper is +1. All these are cuprous ions only. So when diazonium salt or arene diazonium halide or arene diazonium salt reacts with the cuprous ion with respect to halogen acids, and the product what we are going to get, let me move with the first one. So here we are going to get ArCl. In particular, chlorobenzene we are going to get, and a kind of gas is released, that is nitrogen. In case of second one, we are going to get ArBr. Just observe here. So nitrogen is going to be replaced by the nucleophile Br minus. So therefore ArBr we are going to get, and nitrogen is going to be replaced, and here again ArCN we are going to get, and nitrogen gas is going to be released. So in all these cases, nitrogen is replaced by either halide ion like Cl minus or Br minus, and one more is Cn minus, that is cyanide ion. So in all the three cases, nitrogen gas is going to be released. So this reaction is termed as a Sandmeyer reaction. So if you want to define, or if you want to write the statement of a Sandmeyer reaction, what actually we did in this case is Cl minus, Br minus and Cn minus, these nucleophiles, we introduce these nucleophiles into this benzene ring of diazonium salt in the presence of cuprous ions. This reaction we call it as Sandmeyer's reaction. Introduction of nucleophiles like Cl minus, Br minus, Cn minus into benzene ring of diazonium salt in the presence of Cu plus ions is called Sandmeyer reaction. Remember that in Sandmeyer reaction we displace the nitrogen by nucleophiles. like halides, or you can say cyanides. This is the one case what I consider it as A, that is Sandmeyer reaction. Second one I am going to consider B, and that is also a named reaction, and let me write that Getterman reaction it is. So Getterman reaction I am going to consider, and in this case also nitrogen is going to be replaced by halide. Let me write the reaction. I consider arene diazonium salt. Here two reactions I am going to write. The first reaction, when arene diazonium salt reacts with the copper powder in the presence of respective halogen acid. One more is when the same diazonium chloride salt reacts with copper in the presence of hydrogen bromide. So what happens here? In this case, the gas released, the compound what we get is ArCl. Of course, the gas released is nitrogen, and we get CuCl, or you can consider CuX actually, not CuCl. We are going to get CuX because the Cl minus the nucleophile has been attached with this benzene ring. So in the second case, since we have HBr, therefore we get AgBr, and plus nitrogen gas is released, and here we get CuX as the byproduct. So in this case, this is almost as same as the previous one, Sandmeyer reaction. When arene diazonium salt reacts with the copper powder with respect to halogen acids, we get what actually the chlorobenzene or bromobenzene we can say. So this reaction is termed as Getterman reaction. In Getterman reaction, we introduced nucleophiles like Cl minus and Br minus into the benzene ring of diazonium salt in the presence of a copper powder and respective halogen acids. That we call it as Getterman reaction. Introduction of nucleophiles like Cl minus and Br minus into the benzene ring of diazonium salt in presence of a copper powder, we call it as Getterman reaction. We have one more kind of a reaction of the same name, that is Getterman-Koch reaction. Remember that Getterman reaction is different and Getterman-Koch reaction is different. Getterman reaction is about the reaction of arene diazonium salt, whereas Getterman-Koch reaction is actually one of the best method of preparation of aldehyde. Remember that Getterman-Koch reaction is for preparation of aldehyde, whereas the Getterman reaction is the reaction of benzene diazonium chloride, you can say. In both cases, if you observe the Sandmeyer reaction and Getterman reaction, nitrogen gas is released, and of course nucleophiles are going to add into the benzene ring. But if you observe the yield of Sandmeyer reaction and the yield of Getterman reaction, the yield will be greater in case of a Sandmeyer reaction. Try to know that one. So that is about how actually displacement of nitrogen takes place by halide or cyanide ions by considering two well-known reactions, Sandmeyer reaction and Getterman reaction. Second one I am going to move it now. The second one is displacement of nitrogen by iodide ion, that is I minus. So now I am going to displace this nitrogen of benzene diazonium chloride or arene diazonium salt by this iodide. So how I am going to consider that? So I consider arene diazonium chloride I consider. So that has to react with the Ki, that is potassium iodide, because direct reaction of benzene with iodine is not possible or very difficult. Therefore, we need to consider arene diazonium chloride that has to react with the potassium iodide. So when potassium iodide reacts with the diazonium salt, and we are going to get what actually ARI, that is nothing but iodobenzene we are going to get. Benzene ring with iodobenzene we are going to get, and apart from that the gas released will be nitrogen, and we get one more byproduct, that is KCl. So here what happens, nitrogen is going to be replaced by iodide ion. So displacement of nitrogen by one anion, that is iodide ion. Similarly, the next one will see, third one, displacement of nitrogen by fluoride ion, F minus will see. displacement of nitrogen of diazonium salt by fluoride ion. So how actually this reaction takes place? Let me consider ArN2 plus and Cl minus, that is arenium diazonium chloride. When it reacts with HbF4 fluoroboric acid, this is, let me write the name for your reference, this is fluoroboric acid. When this particular diazonium salts reacts with the fluoroboric acid, and we are going to get a compound, let me write over here, I will write here ArN2 plus and BF4 minus we are going to get, and let me write the name of this compound, this is arene diazonium fluoroborate, arene diazonium fluoroborate, the intermediate. And when you heat this compound, when you heat the arene diazonium fluoroborate, we are going to get the halogen of with respect to benzene, that is nothing but fluorobenzene we are going to get, ARF fluorobenzene. And apart from that, we are going to get N2, nitrogen gas is released, and we are going to get BF3, boron trifluoride. So in this reaction also, nitrogen is going to be replaced by what actually this fluoride ion that has to react with the fluoroboric acid. Remember the formula HbF4, and the intermediate what we get is arene diazonium fluoroborate. And after heating that, decomposition takes place, and we are going to get what actually the fluorobenzene we are going to get. So this is how nitrogen can be replaced with what actually F minus. So that is some kind of ions like F minus and I minus can replace nitrogen present in diazonium salt. Fourth reaction, displacement of nitrogen by hydrogen. Fourth one, I am going to talk about how the nitrogen of diazonium salt can be replaced by hydrogen. Let me write over here arene diazonium chloride we have. When it reacts with an acid H3PO2 in the presence of water, this is the one reaction I am going to consider. One more of the same kind I will consider when arene diazonium chloride reacts with ethanol CH3CH2OH, and here the function of these two reagents are same. In the first one I considered H3PO2 hypophosphorus acid, CH3CH2OH ethyl alcohol ethanol we can consider. The name of this compound let me write over here. So this we call it as hypophosphorus acid, and we know this one, this is ethanol or ethyl alcohol. These two reagents acts as a mild reducing agent. These two reagents reduces arene diazonium chloride to benzene, or I can say the nitrogen of diazonium chloride is replaced by hydrogen. So what we are going to get in the first case? We are going to get ARH. In the second case also we get ARH, and some common byproducts we get here. Let me write that nitrogen gas is released and HCl is formed. In this case also nitrogen gas is produced and HCl is formed. In case of first one, we get one more compound, that is H3PO3. In second case, we get a compound like CH3CHO. H3PO2 hypophosphorus acid and H3PO3, that is nothing but phosphorus acid. Phosphorus acid. These are oxo acids of phosphorus. H3PO4 phosphoric acid, H3PO3 phosphorus acid, H3PO2 hypophosphorus acid. Since these two acts as a reducing agent, means these two should undergo oxidation. If you calculate oxidation number of phosphorus in this compound and oxidation number of phosphorus in this coupon, definitely we are going to observe increase in oxidation number, that stands for oxidation. So H3PO2, H3PO3, that stands for oxidation of that reducing agent. In second one we have ethanol, so we have alcohol here. So as we know, oxidation of alcohols, we get aldehydes. So CHO is the functional group, aldehyde, and the IUPAC name is ethanol, I can say, or acetaldehyde you can consider. So alcohol is converted into aldehyde. In particular, primary alcohol is going to be converted into aldehyde, and this reaction we know it as oxidation. So in this particular reaction, H3PO2 and C2H5OH acts as a reducing agent, and that itself undergoes oxidation to form respective acid and respective aldehyde. Remember that in this reaction, nitrogen is going to be replaced by hydrogen, and we get benzene from benzene diazonium chloride. That is reaction number 4. Now the fifth ones will see displacement of nitrogen by OH groups. So how actually OH group is going to replace the nitrogen, we'll see now. So let me write the reaction for that one. That is AR N2Cl plus and minus. As we know, when this particular diazonium chloride undergoes hydrolysis at higher temperature around 283 Kelvin. At high temperature, in particular 283 Kelvin, this benzene diazonium chloride or arene diazonium chloride undergoes hydrolysis. While preparation of this, I explained that arene diazonium salt is stable at cold conditions only, and if you increase the temperature, hydrolysis takes place, and during hydrolysis what happens, there will be addition of OH group to the benzene ring, and of course some other products we get it as common, that is N2 and HCl. In this particular reaction number 5, we displace nitrogen by OH groups, hydroxyl groups. One more reaction we'll see how we can replace the nitrogen by NO2 group. So nitro group, how we can displace the nitrogen of benzene diazonium salt with the nitro group. So let me explain that one. So now here I am going to consider this is a benzene ring and N2Cl. This is as good as you know the benzene diazonium chloride, and when this reacts with the HbF4 fluoroboric acid, as we have seen in this case, what we are going to get here is we get a benzene ring, of course, and here we have N2 plus, and we will be getting BF4 minus, and when this is going to be heated, we get a fluorobenzene as we know, but we are interested in NO2 group, so we need to replace nitrogen by NO2. What we have to do? We have to add sodium nitrite, that is NaNO2, in the presence of copper, and we need to heat that, and during this reaction what happens, there will be introducing NO2 group on this case. So here we are going to get a nitrobenzene, which indicates that nitrogen of diazonium chloride is going to be replaced by NO2 group, and apart from that we are going to get what actually HbF4. Here we are going to get NaBF4, and of course the nitrogen gas is going to be released. So this is how in these three reactions we replace the nitrogen by hydrogen, and nitrogen by hydroxyl group and the NO2 group. Totally 6 reactions I considered. In all these 6 reactions, nitrogen of diazonium chloride is replaced by some standard anions or nucleophiles, you can say. Now we'll see second class of chemical reactions of diazonium salt. That is nothing but chemical reactions involving retention of azo group. So B I consider it as, and here there will be retention of azo group. Retention the group remains as it is. There is no change in the azo group. And this kind of reactions, we call it as coupling reaction. Coupling reaction. So we'll see the examples and we'll define what actually the coupling reaction stands for. Here I am going to consider benzene diazonium chloride. So in this fashion I am going to write here. So this is N2 plus and Cl minus, benzene diazonium chloride. When benzene diazonium chloride reacts with phenol, benzene ring with OH, we call it as phenol, and in the presence of base, what happens? There will be coupling of these two reactions. So OH group we have, and here I consider one hydrogen which is at a para position to OH. So coupling of this group with respect to benzene diazonium chloride, this is benzene diazonium chloride and this is phenol, and after this we are going to get Azo compound. So what is that compound we are going to get? Let me write over here. So here we have a benzene ring and N2 we have here. In N2 actually this will be in this fashion, N2, and here we are going to get the phenolic group what we have here, and the Cl minus is going to be eliminated, and of course we get a water molecule. So these are some other products what we are going to get, and this is the azo, isn't it? And this is the dye, dye, dye stands for color. So azo dye we are going to get here. This class of compounds we call it as azo dye. So azo group we have, it is the dye which imparts the color, you can say. And OH group we have, that is at a para position, therefore the name would be para hydroxy azobenzene, para hydroxy azobenzene. And I told you that one azo dye it is, and the characteristic color is orange. So orange dye it is, orange color this compound is. So here what happens, there will be coupling of para position of phenol with the benzene diazonium chloride, so that two aromatic rings we have. See here, this is one aromatic ring and this is also one aromatic ring. These two aromatic rings are joined by a kind of group, that is bond N double bond N single bond, and this group we call it as conjugated system here. So alternative single bond, double bond, single bond we have, conjugated system I can better say. Therefore two aromatic rings are joined by conjugated system, that is the azo system. Therefore para hydroxy azobenzene, which is orange color dye it is. So this is the one reaction what I can consider, where benzene diazonium chloride reacts with the phenol. One more of the same kind I consider. So this is benzene diazonium chloride, N2Cl. When it reacts with aniline, aniline I am going to write in this fashion. So aniline, benzene ring with NH2 we know, and at para position of course we have hydrogen. I consider this because there will be coupling of these. So this is benzene diazonium chloride and this is actually aniline. So now I hope you can guess what actually the reaction takes place in between these two. So here we are going to get azo dye again. So what kind of azo dye we are going to get? We have a benzene ring and N double bond N. This is the azo group, and one more aromatic group we have, aromatic ring we have here, and that is benzene ring with what actually NH2, and of course we get Cl minus and H2. This is the common thing, and here NH2 amino group which is present at para position to this one. So therefore the name of this compound will be para amino azobenzene, para amino azobenzene, and this is yellow colored dye. This is yellow colored dye. Azo dyes we are going to get, and this is yellow colored dye. So para amino group we have here, whereas in previous case para hydroxy group we have, because the reagents I considered one is phenol and one is aniline. There will be coupling of the reagents I can say here. So these reactions we call it as coupling reactions. In common sense I can say there will be retention of azo group, So in the previous cases, in all the cases here, nucleophiles or ions are going to replace the nitrogen, whereas in this case the nitrogen which is present on BDC, benzene diazonium chloride, that remains as it is. There is no displacement of nitrogen. Nitrogen remains as it is. Azo group remains as it is. Therefore the heading I have written retention of azo group. When benzene diazonium chloride reacts with phenol or aniline, azo compounds are formed, azo dyes are formed. So here the dye, orange dye it is DYE, and here it is yellow dye, yellow colored compound, azo dyes we are going to get, and these reactions we call it as coupling reaction. Remember, in coupling reaction, two aromatic rings are joined by this group. What is that group? This is the group. So two aromatic rings are joined by this group. Therefore this reaction is considered as a coupling reaction, and that is all about the chemical reactions of diazonium chloride. We have seen two different classes, as I mentioned. Chemical reactions involving displacement of nitrogen. One more is chemical reactions involving retention of azo group. So we have n number of applications of diazonium salts. As we know, we can displace a nitrogen and we can carry out the coupling reactions also. So diazonium salts, or in particular benzene diazonium chloride, acts as a very good intermediate for different organic compound synthesis, and that is all about the organic compounds containing nitrogen, one class, that is diazonium salts. That is all about the chapter amines.